Okay, so we are going into chapter 3 now. So the first section is 3.1, evaluate nth roots and use rational exponents. So basically, what we're kind of starting to do within this section is diving into a lot of different kinds of roots, or radicals is what we generally call them, other than just a typical square root. So in this first part of 3.1, we want to teach you how to rewrite a radical or a root as an exponent, specifically a rational exponent. So let's kind of dissect some of those words. A root or radical means that we have this kind of radical bar, square root bar, cube root bar, and so on. We're going to turn that into a rational exponent, meaning an exponent that's a fraction. So we rewrite these for a couple of different reasons. One of the biggest ones is going to be to help us simplify. And we'll kind of get into that further once you start to learn how to rewrite this. But essentially, it'll help us simplify in the end. So when we're rewriting a radical as a rational exponent, the numerator of this rational exponent comes from whatever exponent was already taken for that base. So if this was the square root of x cubed, 3 would be that p. Okay, so then the denominator of this rational exponent comes from what kind of radical or what kind of root you are taking. So again, exponent goes on top, root goes on bottom. So we want to rewrite a couple of these examples down here. The first one is the square root of 2. So first we want to say, what's the exponent that's currently here? If there's no exponent written, we know that that exponent is essentially 1. So it's going to be 2 to the 1 over the kind of root that it is. Again, 1 going to the exponent, the numerator of that exponent, and then 2 is the kind of root it is. So that goes in my denominator. Okay, that's the answer there. Again, just because we're asked to rewrite these. So looking over at this example, the 5th root of 7. Again, the exponent here is 1. So it's 7 to the 1 over the kind of root that it is, which is a 5. So 7 to the 1/5. That's a 5. You can't tell. Ooh, it looks a little wonky on there. Okay. Next one, we throw a variable in here. Cube root of 5x quantity squared. Okay, so a couple of different things here. If you're going to write an exponent in the rational exponent, it has to apply to every term underneath the square or the radical bar. So looking at this exponent of 2, since there's parentheses here, the 2 is applied to both the 5 and to the x. That being said, the exponent of the entire thing underneath the radical is in fact 2, so we can write that in our rational exponent. Okay, so then 3 is the kind of root that it is, so it would be 5x quantity to the 2/3. Notice how I wrote in these parentheses. This is again saying that this exponent is applied to everything within the parentheses. So we know from exponent properties that if I didn't write these parentheses, it would only apply to what it's touching. So that would be the x. Okay, so I have to write around everything. Let me add in a little bit to this problem. Okay, so up above in this example, we actually wrote in 2 as the kind of root that it was. The base of, or the typical root you see is a square root. So just like up here, how we said, oh, if there's no exponent written, that exponent is already 1. The same kind of thought applies to a root. If you do not write a number out in front, it is in fact a square root. Okay, that's the first root that we ever talk about. It's the kind of base radical. So if there were no number out here, you assume that it's 1. Or sorry, 2. Backtrack there. So now let's talk about the exponents. 6x squared. So it's not 6x quantity squared, it's just 6x squared. So the square's only applying to the x. Since it's not applying to the 6 as well, we cannot write it in our rational exponent. So our rational exponent will still just be 1 in our numerator. And this 2, oh, you cannot see what I'm doing. This 2 comes over to the x, okay? So it's still going to be applied to the x. It was a square root, so that goes in our denominator. So 6x squared quantity to the 1/2. Okay, remember those parentheses. All right, so again, just a little note down here. When no number is written in the radical, it is a square root, meaning that your denominator of this rational exponent would be 2. So now let's rewrite rational exponents as radicals. We're going to go backwards. This time we're starting out with a rational exponent and getting it into a root. So I'm going to go ahead and write a radical bar. The inside is going to be 16. Okay, we know that because that's what's being taken in that rational exponent. Numerator is the exponent, so 16 cubed. Denominator is the kind of root. I'm not going to write a 2 here because that's essentially a square root. Again, square roots do not need to be written. Since it's a square, you just kind of leave it in there. Okay, so that one's done. So go write this one. The first thing that we have to kind of deal with is the fact that this is a negative exponent. When we have a negative exponent, that means you take everything to the denominator and you make it positive, right? We know that from exponent properties. Now let's deal with the fact that this is a root. So it will be 1/32. The kind of root will be a 5th root. The exponent, oh, I changed that to a 2, sorry, it should be a 3. The exponent is 3. Okay, that would be my final answer there. Let's go over the next example. Just a simple n to the 9. I don't know why I said n. 9 to the 1/5. That would be 9 in a radical bar, exponent of 1, so I don't have to put anything. Root of 5. So 5 goes out in front. All right, and we just keep on moving. Okay, so 64 to the negative 2/5. Again, take that to the denominator, make that exponent positive. Oops, can't see that. And now let's do with the radical, the rational exponent, make it into a radical. 64, the exponent's going to be a 2, and the root will be a 5. All right, so those are rewriting, going back and forth essentially between square roots and rational exponents and radicals. So the very last thing I just kind of want to show you is how do we put this into a calculator? Okay, where is, let me find my calculator. So if you have a TI-83, 84, go ahead and grab that out. I want to show this to you. Okay, so you know, and again, you're going to have kind of a hard time seeing my calculator. So I'm going to show you the buttons while it's off because it's easier for you to see what I'm doing while it's off. And then as soon as I turn this light on, everything goes crazy. So the square root itself is right above, and let me try to bring it closer to see if you can see it then. There we go. So the square root itself is right above that x squared. So in order to get a square root, you would press the second button and then x squared. to get a square root, okay? But what if we want to find something that's not a square root? Okay, let's say, I'm going to have to focus this again. Let's say we want to get something that's more like a fourth root of a number, or a sixth root of a number. We have to take a different process in that. We don't just have one specific button that just ding goes to the sixth root. So what we will do is go to the math button, okay, and you're going to have to scroll down to a thing that looks like an X and then a radical bar and hit enter, okay? So I'm going to do it on my calculator, and you're not really going to be able to see it. We'll try. So for me to try to put in fourth root of 55, you can do this either way. I like to put in a 4 first, okay, and then again I go to the math button. And you're not quite going to be able to see exactly what it looks like on my calculator, but you should have an X and then a root bar, okay, again, an X root bar. Hit enter. It automatically will put that 4 or whatever number you typed in. Again, I put 4 because that's the kind of root that it is. It will put that up in that root position. And then you go ahead and type in 55 and hit enter. If you did it correctly, you should be getting 2.72. Okay, so let's practice that again with the sixth root of 78. So I'm going to hit 6 first, because that's the kind of root that it is. Go to math. Mine is number 5. And then hit 78, enter. If you did that right, you would be getting 2.06. Okay, that is all for 3.1. Super short, kind of just a good introductory lesson to getting into some of these rational exponents.